All right, section 10.2, limits continued, question 24. We're evaluating this limit, which is going to be the limit as r approaches infinity. It's going to have r cubed on the numerator and r squared plus 1 in the denominator. So the trick that we've been using of dividing both the numerator and the denominator by the highest power of the denominator helps when the denominator has a higher power of the variable than the numerator. But in this case, the numerator has the higher power, and so it's not going to result in such a clean sort of limit as we've had thus far. I'm pretty sure we're going to reach infinity. And another sort of trick that we've learned in this chapter is that you can evaluate functions like this, rational functions, by just looking at the highest power of each of the biggest terms. This is equivalent to looking at the limit as r approaches infinity of r cubed over r squared, because as the numbers get bigger and bigger, it's only these large sort of cubed and squared terms that are going to matter in terms of what's going to be the sort of result of each of these functions as we plug in larger numbers. And so we can estimate the limit by just looking at this expression here, rather than having to include this plus 1 in the denominator. Obviously this is a very simple function, but there's more complex rational functions that have more complex expressions in the numerator and denominator, which then make it easier to manage in terms of evaluating a limit if we just kind of use this method of just looking at the terms with the highest powers. Anyway, so let me just demonstrate the fact that why we can't use the same trick we've been using. So we would use 1 over 3 squared over 1 over 3 squared. So we're multiplying the expression by 1, essentially, the highest power of the denominator. So in the numerator we have r cubed over r squared, in the denominator we have r squared over r squared, and so the result is we have r over 1, which is r. So we've really gotten nowhere because r cubed over r squared is r, so that trick did nothing, and so that's why you don't apply it unless the denominator has the same or a bigger power than the numerator in a rational function. So in this case, because we basically just have r and we're looking at what is the limit as r approaches infinity, well, as r approaches infinity of r, I'm pretty sure the limit is going to be infinity, and so that is going to be our answer here. Infinity. A fun answer and a very simple answer. Thank you.